I did a small study on the prices of certain commodities, of a few commodities in the United States for the last few decades. Those prices are both in terms of gold and US dollars, and then I compared the two to try to get an idea of what's been going on with the US economy and to try to also find out what's been going on with the purchasing power in the United States. This first graph is an introductory graph. It's the price of gold since 1900 in terms of dollars. And you can see how the price is mostly stable up until 1971. 1971 is when Richard Nixon effectively removed the gold standard in the United States, making the US dollar a fiat currency as opposed to a gold-backed currency. Since then, the price of gold, instead of in terms of dollars, has skyrocketed, especially in the last decade, starting around 2000 or 2002. As you can see in the graph here, is the last part of the graph, how the prices of gold have gone up. The first commodity is domestic US oil, and this one, I have data for this starting in 1947. Now, when we look at the price of oil in US dollars, this is the graph we get for that period of time starting in 1947. And you can see how it's gone up. This black line here is a regression line. It's an exponential line that best describes the changes in the price of oil over that period. I opted to go with the exponential line because it's the one I thought best described this graph. The linear line did not represent it quite as well as this one does. You can see how the prices for oil have gone up since the early 70s, and they have spiked starting in around 2000, 2001. The second graph here is the price of oil, of domestic US oil, and this for the same period of time, but this one's in terms of gold ounces. You can see how the graphs are different, and the black line here is a linear regression line that I think better describes this graph. And you can see the equation for that line here. Y equals minus 0.0003x plus 0.0828. Now I tried to make that easier to understand, so that we don't have such small numbers on that equation. So what I did is I multiplied it by 100, and we end up with y equals minus 0.03x plus 8.28. So that would be the graph, or the equation for 100 barrels of oil in terms of gold ounces, as opposed to just 1 barrel. Now the ratios remain the same, which is the important thing here, but the numbers are a lot easier to understand. So if we focus on that last equation, what that equation means is that if in 1947 the price of oil was 8.28 gold ounces for 100 barrels of oil, you would have to add, or in this case actually subtract, 0.03 ounces of gold each year to come up with the price of 100 barrels of oil for that year. So basically, if in 1947 the price was 8.28 gold ounces, then in 1948 it would be 8.25 ounces. In 1949 it would be 8.22 ounces, and so on. So you can see how the price of oil in terms of gold has not changed that much over the years, and the small change it has is actually going down. So the price of oil in terms of gold has slowly gone down over the last 65 years or so, as opposed to the graph we saw of oil in terms of US dollars, where it's continually gone up, especially in the last couple of decades when it's gone up real fast. This next graph is for the price of residential natural gas in US dollars, starting in 1982, and you can see how it's gone up over time. And the black line is a linear regression line that best describes the changes of the price of natural gas over that period of time. The equation for that line is y equals 0.2929x plus 3.5925. So what that equation tells us is that in order to describe in a linear way the yearly changes of the price of residential natural gas in terms of US dollars in the US, we could assume that the price and that price, by the way, is in 1,000 cubic feet. So 1,000 cubic feet, according to this regression line, was $3.59 in 1982, and we would have to add roughly 30 cents each year to come up with the price for that year. So that is that's a significant increase, yearly increase. If you add 30 cents each year to a commodity that started at $3.60, so $3.60 one year, the next year it would have been $3.90. The year after that it would have been $4.20, and so on, in terms of US dollars. Now here's the same exact commodity in terms of gold ounces, and you can see how it has also gone up over time in terms of gold. However, the rate of increase is not as much as it was in US dollars. This regression line has also very small numbers. You can see the equation within the graph, but I changed that and I multiplied it by 100. So instead of dealing with 1,000 cubic feet, the price of 1,000 cubic feet of natural gas in terms of gold ounces, if we deal with 100,000 cubic feet, then the equation that we have is y equals 0.05 plus 1.3. And that means that if in 1982 100,000 cubic feet of natural gas was 1.3 gold ounces, then you would have to add 0.05 gold ounces for each year in order to explain what happened with the actual price. So if in 1982 the price was 1.3 gold ounces, then the next year, 1983, would be 1.35 gold ounces. 1984 would be 1.4 ounces, and so on. So there is also an increase here. But if we compare it with US dollars, that first year increase in US dollars from $3.60 to $3.80 represents an 8.2% increase for that first year. If you price it in gold ounces, the change from 1.3 gold ounces to 1.35 gold ounces is it's gone up 3.85%, as opposed to 8.2% when measured in US dollars. So we can conclude here that the price of natural gas has gone up both in terms of gold and US dollars, but at a lot faster rate in US dollars than in gold. This next graph shows the price of a pound of sugar in terms of US cents, not actual dollars, but cents, over time, starting in 1971. And you can see the black line there is a line that best describes that graph. That one is a polynomial regression line that I used that one because I thought it best described those price movements over the years. You can see how initially, starting in the 70s, the price of sugar was going down, and it continued to go down for a couple of decades. Then in the late 80s through roughly 2000, it stayed fairly the same throughout that period of time, and then it started going up again, starting in 2000 or 2004 or so. If we use the linear regression line here, we would see that line would be almost straight, meaning that the prices for the pound of sugar, the price of sugar over time in this period, have really not changed that much. Although I didn't use that linear regression line because this line here, I think, best describes it. As you can see, the price is going down in the first part of the graph and then going back up again in the right portion of the graph. If we use the same commodity here, sugar, priced in gold, we get this graph here. This graph shows the price of 1,000 pounds. This is 1,000 pounds of sugar in gold ounces. I didn't use just 1 pound because then the numbers would be way too small. But 1,000 pounds of sugar in terms of gold, this is what it looks like. It's the blue line on this graph. The black line is the regression line that I used, which is an exponential line. And it shows you how the price was going down for the first couple of decades in this graph, and then stayed fairly the same over the last 2 or 3 decades. So as opposed to the last graph, when the price of sugar was going back up in the last decade or two. In terms of gold, the price of sugar is still going down at a very small pace, but still going down. And if it's not going down, it's at least maintaining its price. So in terms of US dollars, it's more expensive. It's getting more expensive now in terms of gold. You continue to pay the same as you have for the last decade or so for sugar. The next commodity I studied was gasoline. This graph here, the yellow, or rather the blue line, shows the price per gallon in the US over time starting in 1979. The black line is a linear regression line that describes that graph. And you can see the equation there, which tells us that if in 1979 the gallon was 56 cents, then in order to describe the prices, the price changes over the last 35 or so years, you would have to add almost 7 cents each year to that gallon of gas. So in 1979 it was 56 cents. According to the black line, in 1980 it would have been roughly 63 cents. The next year it would have been 70 cents, then 77 cents, and so on, to get to the point where we're at right now. Now, the black line really doesn't get to the point where we're at now, because the price has gone up a lot more rapidly over the last few years. And you can see that differential where the blue line ends and where the black line ends. According to the black line, the price of a gallon of gasoline in 2012 should be somewhere around like $2.30, when in reality it's way over that. But that's because of that spike in the price over the last few years. The black line still represents most of the graph, or all of the graph actually. In this graph we see the price of a gallon of gas over the last 35-ish years, but this one's in terms of gold ounces. So for this one I multiplied it by 100, so we're looking at the prices of 100 gallons of gasoline in terms of gold. This is purely for better understanding. The rates are, again, they're the same. It's just that the numbers are easier to understand if it's 100 gallons as opposed to 1 gallon, because the price of gold is so expensive or so high compared to the price of gasoline. So in this one we see the equation for that regression line, which is 0.0032x plus 0.3076. So that means that if in 1979 you wanted to buy 100 gallons of gas, you would have to pay with roughly a third of an ounce of gold. And each year you have to add 0.0032 ounces of gold to keep up with the price of gas in terms of gold. So you can see how it's gone up over the years, but the rate of increase is really small. And that's why the slope for that black line is not that high. It's definitely not a straight line, but it's not going up too fast either. So if in 1979 you had to pay 0.307 ounces of gold for 100 gallons of gas, the next year, 1980, you'd have to pay 0.310 ounces of gold, and the next year 0.313, and so on. So you see the change there is not nearly as much as it was when we were looking at the price of gold, or the price of gas in terms of US dollars, when you had to add 7 cents on that second year after it was 56 cents. So there's a very noticeable difference between the two. So what we can conclude from this is that the price of gas in terms of gold has remained roughly the same over the years, gone up just a little bit maybe. In terms of dollars, it's gone up a lot faster. Also notice how the price of natural gas has gone back down since the high of the early or mid 2000s in terms of gold. In terms of dollars, it's not come back down yet. Now this graph shows the median price of houses sold in the US for each year, starting in 1963. These are not average prices, but median prices, meaning that if you divided all the houses that were sold in each year into two groups according to their price, and you had the most expensive ones in one group and the most or the cheapest one in the other group, then the median price is that is in the middle of those two groups, the one that's right in the middle of the two groups. And that's what we see here for each year in with the blue line. starting in 1963, and the black line is a linear regression line. Now for this one I had to set the intercept at 0, because if I didn't, then the black line would go under the x-axis, meaning that that house prices were negative at some point, which makes no sense. If I left it like that, it would only show the prices of homes going up even faster in terms of USD. But for the sake of simplicity, or to make it easier to understand, I set the intercept at 0 so that we don't deal with negative prices for homes. And what we're left with is 4,531.4x equals y, and that's that black line. What that means is that in 1963 the price of the median house sold in the US was 0. Then each year you would have to add $4,500 to the price you paid for that house each year. So in 1963 it was free. 1964 it was $4,500. 1965 it was $9,000, and so on until you reached 2011. And you can see that line describes very well the movement of the blue line, except maybe for that spike in the prices at the beginning of this last decade. And that right there is the housing bubble, which was predicted by Austrian economists such as Peter Schiff. Then we move on to the prices of the median house sold in the US for each year, but this one's measured in terms of gold ounces. And that's the blue line here on this graph. You can see how it's really different from the graph of the price in terms of US dollars. And then the black line is also a linear regression line. The equation for that is minus 2.8x plus 453, or roughly 454. So what this means is that if in 1963 you would have to, if you pay 454 gold ounces for that house, then the next year you would have to pay 2.8 gold ounces less. And that is true for every year after that. So every year you would have to pay 2.8 gold ounces less than the previous year for the same, or for the median price house of that year. So in reality, what that says is that in terms of gold, house prices in the US have gone down over the last 50 or so years, as opposed to it going up very fast in terms of US dollars. Now you can see this this graph here also shows that housing bubble. But in this case, you also see how the prices of homes have gone down over the last decade, as opposed to the graph of houses in terms of US dollars, where they went down a little bit and then they recovered in the last couple of years, or last few years. According to this graph here, in terms of gold, there's really no recovery. And lastly, I looked at median household income in the US starting in 1967. When we measure that in US dollars, it looks like families in the US have continued to become wealthier over the years, almost without exception. Maybe 2008, 2007, there's a small regression there, but for the most part, it shows that households in the US are wealthier each year if you measure that wealth, or that income rather, in US dollars. you can see how in 1967 the income was roughly $5,000, and in 2012 it's roughly $50,000. So it's gone up by a multiple of 10 over the last 45 years, according to this graph in terms of US dollars. I didn't add a regression line on this one because that line is almost a straight line, so it would almost be the same thing. It gives you an idea of the income for families or households in the US in terms of dollars. But when we look at that income in terms of gold, which we've not really established, but we have a pretty good idea now that gold is a lot better at maintaining purchasing power than the US dollar is or has been. And it's a lot better at maintaining its value over time. So if you were to buy gold immediately when you got paid every year or every month, then this is what your income would look like. Your yearly income would look like over the last 45 or so years. And you see that this graph shows that the median household income has actually gone down over the years. In terms of gold, families have actually lost purchasing power. As you can see here, the purchasing power or the income went down for the first part of the 1970s decade, and then it went up a little bit again, and for the last decade or so it's gone down again. And in total, as you can see with that black line, it's gone down every year. The equation for that line is y equals minus 1.129x plus 118.05. So what that tells you is that if your income in 1967 was 118 gold ounces for the year, every year after that you would have to subtract 1.1 gold ounces, or let's say 1 gold ounce every year that you earned less than the year before. So in 1967 you earned 118, right? So the median household in the U.S. was 118 gold ounces in 1967. It was 117 the year after that, 116 the year after that, if we try to describe it in a linear way, which is what we're looking at here with the black line. And this graph here is an extra graph that I did, where I put the two graphs together in the same graph, and to do that I found what the average were for each of the two. The average income over that period of time in terms of US dollars was, or not, the average median income was $27,000, 657. The average median income was 91.5 ounces a year. And what this graph here shows is how much each year deviates from that average. So if the income for a specific year was exactly that average, then the deviation was 0%. As you can see, for example, in the red line, which is gold, in 1972 it crosses the x-axis at 0%. 1972, meaning that in 1972 it was real close, the median income was real close to 91.5 ounces. And that's also true for 1992. For the blue line, which is median income in US dollars, the line crosses the axis roughly around 1989, meaning that the median income for 1989 was roughly the average income for the period of time, which is $2,700, or $27,000 rather. Now, what this graph shows us is the difference between these two, and from your observation and your empirical evidence, what you see every day and what you've seen over your life in the US, which graph would you say best represents what's been going on in the US for the last few decades? According to the income in terms of US dollars, your purchasing power should have gone up invariably over the last decades, with the exception possibly of 2008 when it went down just a little bit just to go back up again the next year or so. But if you measure that in gold, which is real money, with real purchasing power and real value, you see how the income of households in America has gone down almost every year starting in 2000. I would say, and this is an opinion, not a fact of course, but I think it's a popular opinion that the actual purchasing power of US household over the last decade has actually gone down and not up, as the blue line suggests. So if that's also your belief, I would suggest also that we started looking at prices in terms of gold, in terms of money, instead of looking at them in terms of dollars, because we're just getting false data if we take into account price in terms of US dollars. Because the US dollar now, since 1971, has no intrinsic value. You can, or not you, but the Federal Reserve can print as many dollars as they want, and they've been doing so, devaluing the price of the dollar. But they cannot, or no one can actually devalue the price of gold by inflating it. There is a specific amount of gold in circulation, and you cannot just print gold. You have to actually mine it, so it has intrinsic value, and that's the difference between measuring prices in money and measuring prices in dollars, in paper. One will give you a better idea of what's going on in the economy. That's money, in this case gold. The other is going to basically tell you what the Fed wants you to think. So if the Fed wants you to think we're in a recovery, then all they have to do is inflate. All they have to do is print. And then you get a nice looking graph like that, blue line there, where it looks like over time people have become wealthier and have had more yearly incomes over the last 6 or 5 decades or so. So in conclusion, if we used money, it doesn't have to be gold, but money, instead of fiat currency, instead of paper currency, then we would be able to better understand the changes in the economy. The data that we got from the economy would better describe those changes. And also those changes would happen a lot less rapidly. A lot of knee-jerk reactions would not be taking place with a gold standard or any other type of money. And so we would be more suitable to forecast the economy and to adjust to those changes within the economy, both at the micro and macro level. And most importantly, your true income, your purchasing power would go up. Except, of course, if you took pay cuts every year, then it would go down, of course. But in general terms, it would go up. Your purchasing power would go up, as opposed to your nominal income going up, but you being able to buy less stuff with it, as you saw with the price of houses, oil, basically all of the commodities that we saw here. And there's a lot of data that you can also research for other commodities, and I'm sure you'll find the same pattern, where gold will maintain its value and its purchasing power over time a lot better than fiat currencies will.